Hello everyone. Let's start our today's class. In the last class, we discussed about the directional derivatives. If anybody have confusion, then ask. Otherwise, we are going to start a new topic, that is maxima and minima. So let us recall what is maxima minima in one dimension. Like if we are having a curve, like this is x-axis, this is y-axis, and suppose a function it is defined something like that.
Is this a new chapter?
Yes, this is 12.8 exercise. Okay. Like we have started with the function of two variable, domain, range, continuity. We have discussed, like continuity is discussed already. Differentiability. So like partial derivatives, directional derivative we have discussed. And differentiability like partial derivative. अगर आप dimension से compare करें तो like first we define function, we discuss about the domain and range of the function, then continuity, differentiability. Here it is two dimension case, that's why we are discussing about the directional derivative, because and if it is one variable, then we discuss like maxima minima. So now we will discuss maxima minima for the function of two variable. So in this particular topic, like function of more than one variable, this is the last topic, maxima and minima. Okay, so it is the part of same topic, like 12th chapter. So let us recall what is the maximum and minima in one dimension. Okay. Suppose a function that is defined between a and b. Okay, so what are the local maxima? So these are the point. This is called local maxima. And the point inside the domain, if we're talking about, so these are the local minima. Local minima. Okay. Suppose we are talking about, just a minute, I want to make a small change here. This kind of. Okay, so this is what? This is local maxima. All are aware about it. No? So this is local maxima. If we are talking about global maxima, so out of this, whatever the maximum, that we will call as local maxima. Sorry, global maxima. It is global maxima. Okay. Global maxima. And global minima is what? If we see, like, if we compare these two, then maybe we are having something like that. Yes. So this is your global minima. So out of all minimum point, whatever is the minimum value, that will be your global minima out of all minimum point. Hai? Global minima. Okay. So I think everybody is aware about it. Like you have already discussed a study about it. How to compute maxima and minima in one dimension? Given a function fx inside the interval ab, as we specified here, the function that we are defining inside the interval ab, and this is the graph of this function. Okay, this is the graph of this function. So it is containing not many maxima or minima, finite number of maxima and minima, and these are the local minima. If we see like local maxima, if we see like these point nearby, this point here. Okay, so this is the maximum point. If we see in the neighborhood, in this neighboring, so this is the maximum. That's why it is local minima. Similarly, here, if you see, it is local minima, local maxima. It is local maxima. Okay, if we see in out of all these maximum point, which is the maximum point. So this is the maximum out of all these three maximum points. So that's why it is global maximum. Similarly, here we are having these local minima, like if we see surrounding points. Okay. So how to compute mathematically maxima and minima of a function fx that is defined inside the interval AB. So first is compute f dash x equal to 0. Okay, and then check whether the point is, so whatever the value of x is coming out to be, that will be the maximum and minimum value. That would be the point where the function may have maximum or minimum value. Okay, so this is the first procedure to compute maximum minimum of the function fx. Okay, so put fx equal to 0, get the values of x and x. That may be the critical point. Critical point means what? It may be maxima or minima for the function, maximum or minima point for the function. Okay, second is what? At the boundary, we will check function value at the boundary also. So at the boundary, that is at x equal to a and x equal to b. Okay, third is a point.
Derivative.
Yeah, a point inside the interval AB where f dash x doesn't exist. It may be the point where the function is having maximum or minimum value. So this point is what? Like suppose the function is something like that. Okay, something like that. So you're having sharp corner here. So it can also be a maximum point, not always, but depend on the situation. So this is what? This is this kind of situation where f dash x does not exist. So we can also consider function may have maximum or minimum value at this point. Okay, so these are the three criteria on which we are, on these basis we can say like function is having maximum minima at this point. Okay, so this is related to one dimension case, but here we have to talk about two dimension. Okay, I think everybody is familiar with these three condition where the function is having maximum minima. Now let us talk about function when the function is having a function is of two variable. Okay, so let us suppose function is of two variable. F is the function of x and y. Okay, suppose this is the function fxy, and suppose it is the domain of the function fxy, and it is surrounded by some boundary. It is boundary. जैसे कि like अगर हम one dimension की बात करते हैं, then it is defined inside some interval. Okay, this interval AB. But whenever we are talking about function of two variable, then we are saying like it is having some boundary. Boundary may or may not exist, it depend on the function. So we can also define this is the function x. If we are talking about two dimension, like suppose there is some domain, maybe it is the domain. This is x equal to a, x equal to b, and y equal to c, and it is y equal to d. So we are saying like this is the boundary of this function, and this is the boundary. Okay, this one. So we can say the domain of the function is what? Set of all x comma y such that x is lying between a to b. This is one way to define boundary of the function. It depends like what kind of shape of that boundaries happen. Okay, so here in the case of two dimension, possible point of maxima and local maxima and local minimum. So possible points of local maxima and minima. First is interior point. Like whenever we are talking about two dimensions, obviously it is having boundary, then we are saying where the function have maximum minimum inside the domain. So whatever the point inside, like we are talking about, there are lot many points, those are inside this boundary. That for that we are writing interior points where f of x equal to 0 and f of y equal to 0. Since we are talking about two dimension, so we have to take partial derivatives, fx equal to 0 and fy 0. As in the case of like in the case of one dimension, we are having derivative of the function is equal to 0. But when we are dealing with two dimension, then we cannot write directly f dash equal to 0. That means what we are saying, where the function may have maximum minimum, wherever fx equal to 0 and fy equal to 0. That means derivative of function with respect to x and derivative of the function with respect to y. So this is one possibility. Second is what? The interior points where either fx or fy. One more point, that is what? The interior points where either fx or fy or both does not exist. Both does not exist. We can compare with the third point here, where f dash does not exist. So in this case, interior point inside the interval where either one of these two derivative, fx or fy, or both does not exist. That may be the point where function may have maximum or minimum. Third point is what? The boundary points. Boundary points. ठीक है ना? So maybe some point on the boundary. Okay, like any point on the boundary where function may have maximum or minimum. So local maxima and minima can occur only at the critical point. What do you mean by critical point? That I'm going to define. Critical points or boundary points where fx equal to 0 and fy equal to 0 or both does not exist. Critical point का मतलब क्या होता है? Point where fx equal to 0, fy equal to 0 or fx is not like fx or fy or both does not exist. है ना? So these are called critical point or at the boundary points. Okay. So same as in one dimension. Okay. Let us discuss about what kind of situation may occur whenever we are talking about two dimension or more than two dimension. So if we see like there's mountains or valley, so this kind of figure, like you can just imagine, if you see a mountain from outside, then it will look like one dimension. है ना? अगर आप इसको देखते हैं तो it is looking like one dimension, है ना? But if you see it, it is like a valley, this kind of. Okay, or there's a cup, it is kind of ball. Okay, and you are just keeping it like in this, like that. So this is kind of mountain. Okay. So maximum minimum is what? Like whenever we are talking about two dimension, three dimension, then this kind of situation may happen. So mountain is what? Like if you are seeing is it from outside, then it looks like one dimension. But if you will visualize it, it is like a cap, you can say, or it is a ball, like you are keeping it in this way. Okay, so this is what local maxima. Whenever we are talking about in two dimension, local maxima, this is local maximum. Why local maximum? If we see in the surrounding, so this is the maximum point. If we see here in the surrounding, it is the maximum point, like that. Okay. Similarly, these are the local minima. Let us see here. Like that. Okay, it depends. So suppose there is a surface z equal to fxy, then in two dimension, it is situation will be like that. So how to compute mathematically maximum minimum point? By this procedure. Just compare derivative is equivalent to 0, or whatever the point of fx, whatever the point or whatever the value of x and y we are getting, that is called critical point. Okay, we can also write it in a proper graphical, in a mathematical form like that this time around. This is not the case actually. Just wanted to define critical point. So an interior point of the domain of the function fxy where fx, fy are 0, or where one or both of fx, fy do not exist is called critical points. So critical points are what point? Whenever we are comparing fx and fy is equal to 0, and whatever the value of x and y are coming out to be, those are called critical point, or fx and fy does not exist. So that is right. Critical points. It is critical points. Critical points are those points where fx equal to 0 and f of y equal to 0, or fx or fy or both does not exist. Yeah. So those are called critical points. Okay. So let us do one simple example, then it will be more clear.
Ma'am, in the exam, they can also ask us definitions.
No, not definition. It is for your understanding. Okay. Next example. Find the local extreme values. Okay. One more thing I just want to introduce. Let me write this example then. Of fxy equal to x square plus y square. So these critical values, critical point where maximum minimum of the function occur, and these values are called extreme value of the function. Okay, maximum and minimum value of the function are called extreme value of the function. Okay, so this local extreme value, that means local maximum or minimum values. Okay, of the function fxy. So the same. Now, so function is what? That is fxy equal to x square plus y square. So if we talk about domain, like whole xy plane is the domain of the function fxy. Okay, like for all value of x and y it is defined, so whole r square is the domain. Okay. So domain of the function is what? R square. So possible points where the function fxy have maximum minimum value, that is fx equal to 0 and fy equal to 0. We just compared with the fx equal to 0 and fy equal to 0. Okay. So I just write possible points where maxima and minima occur are the critical points One more thing, like I told you here, where the maximum minima occur, fx, where the fx and fy equal to 0, or where does not fx fy does not exist, either one or both does not exist. And third is what? Boundary points. If we are talking about boundary point for this function, what are the boundary point? What are the boundary point for this? Yes.
मैम fx और fy दोनों simultaneously 0 होने चाहिए?
नहीं, इसमें हमने लिखा है ना, simultaneously 0 नहीं होना चाहिए. Interior point where fx equal to 0 and fy equal to 0, और second point में आप देखिए ना, the interior point where either fx or fy और बोथ डज नॉट एग्जिस्ट। हो सकता है fx 0 हो बट fy एग्जिस्ट ही ना करे, ठीक है ना, और हो सकता है इन दोनों में से कोई भी एग्जिस्ट ना करे। तो ये दोनों पॉइंट को मिलाकर हम डिस्कस कर रहे हैं। क्रिटिकल पॉइंट आर दोस पॉइंट वेयर ईदर fx इक्वल टू 0 और fy इक्वल टू 0 और बोथ आर इक्वल टू 0 और बोथ डज नॉट एग्जिस्ट, अंडरस्टैंड, और एनी वन ऑफ these fx और fy does not exist, ठीक है ना। तो क्रिटिकल पॉइंट आर दोस पॉइंट। तो जरूरी नहीं कि साइमल्टेनियसली 0 हो। पॉसिबल पॉइंट पे अगर 0 होते हैं तो लाइक आपको since you are having function of two variables, so you may get some equation so that you can compute x and y if both are 0, otherwise not. Let us do this example now. Possible point where maximum minimum occur are the critical points. Okay, since in this particular example fxy equal to x square plus y square, what are the boundary point? If we are talking about boundary point, what is boundary point for this function? If we like fxy equal to x square plus y square, domain is what? Whole x and y. So there is no boundary for this function, because if you draw it, suppose fxy we are taking as fxy equal to 1, what you are getting? X square plus y square equal to 1, x square fxy equal to 2. So it is what, like it is a circle, x square plus y square equal to 1 if we are giving one value to this. Okay, if we draw it, so it is going up to infinity,
Circle.
radius one circle. If we are giving fxy equal to 2, or we are giving any value, arbitrary value, we are getting different circle like that. So it may circle, and we put all circle together, so it is going up to infinite. So there is no boundary specified na in this case. So that's why there does not exist any boundary point. Understand? अगर हम x square plus y square की बात करते हैं तो there is no boundary because it is whole r square. So possible point where maximum minima occur are the critical points, not boundary points. ठीक है ना, not boundary points. इस केस में boundary exist ही नहीं कर रही है. Points as no boundary.
मैम ये रिपीट कर दो।
Just a minute. अगर हम इस फंक्शन को देखते हैं fx equal to x square plus y square, ठीक है, तो आई एम राइटिंग डोमेन ऑफ दिस फंक्शन इज व्हाट? r square. r square का मतलब है like whole, like it is like for all value of x and y it exists. So it is going from minus infinity to plus infinity in the case of x, as well as in y it is minus infinity to plus infinity. So it is not having any boundary, ठीक है ना, whole r, like x is what? X is belonging to r. r का मतलब क्या होता है? Minus infinity to plus infinity for all values of, and y is belonging to minus infinity to plus infinity. So it is not called as boundary now, because it is going up to infinite. That means very, very large number. So that's why there is no boundary. That's why we are not talking about boundary points. ठीक है ना, like we have already discussed maxima and minima occur at the critical point or at the boundary point. तो क्रिटिकल पॉइंट के बारे में अभी हम बोल रहे हैं, इट में अकर एट द क्रिटिकल पॉइंट, बट फॉर बाउंड्री पॉइंट वी आर सेइंग देयर इज नो बाउंड्री फॉर दिस पर्टिकुलर फंक्शन x स्क्वायर प्लस y स्क्वायर, ठीक है ना। तो दैट्स व्हाई वी आर नॉट टॉकिंग अबाउट बाउंड्री, बिकॉज देयर इज नो बाउंड्री फॉर दिस पर्टिकुलर फंक्शन, बट देयर विल बी सम एग्जांपल्स देयर बाउंड्री में एग्जिस्ट, देन विल टॉक अबाउट इट, ठीक है ना। तो लेट अस टॉक अबाउट now find the local extreme value of the function fxy equal to x square plus y square. Now f of xy equal to x square plus y square, then f of x equal to 0. fx equal to 0 means what? That means 2x equal to 0. Yeah. So it implies that x equal to 0. And also we will compute fy equal to 2y equal to 0. So this implies that y equal to 0. So x equal to 0. So x equal to 0, x equal to 0 and y equal to 0 are the point where fx and y equal to 0. So we can say 0, 0 are the critical point, critical points for the function fxy. ठीक है ना? So understand? So 0, 0 are the critical point. Now we have to check but whether it is a local maxima or local minima or not. If we are talking about like in this question, what is asked? Find the local extreme values, either maximum or minimum. Local. Okay, they're talking about local. So local means what? Let us talk about 0, 0. So 0, 0 is the point where maximum or minimum may occur. We don't know whether it is maximum point or minimum point. So the only critical point is what? 0, 0. If we are computing function value at 0, 0, what is coming out to be? It is 0. ठीक है ना? So function value is what? It is 0 at the point 0, 0. Now let us discuss whether it is a local maxima or local minima. So if we draw the graph of this function, so what is coming out to be? Like I already told, it will be what? Like x square plus y square. This is the 0, 0 point, and it is always positive. So it will go something like that. I told you like the circle of different areas. We are putting together, so it will go to something like that. It depends. Okay. So x square plus y square equal to 0 and 0 0.1, 0 0.2. So it will form this kind of shape. So it is going up to infinite. It is going up to infinite. So 0, 0 is the point that is minimum, and all other point, if we go like upward, then all are point that is greater than. So there always exists a point f of xy that is always greater than f of 0, 0. So this point is what? This is the x and y are what? Any value. X and y are what? Those are different from 0, 0, but it is in the neighborhood of 0, 0. So we'll say this 0, 0 is local minima. So there always exists a point that is greater than this of 0, 0. So we'll say 0, 0 is the local minima. Is it clear or not? देखिए मिनिमम क्या होगा अगर हम उसके नेबरहुड में किसी भी पॉइंट पे जाते हैं, ठीक है, सपोज हम वन डायमेंशन की ही बात करते हैं, सपोज दिस इज मिनिमम. व्हाई इट इज मिनिमम? बिकॉज इसके नेबरहुड में जो भी पॉइंट है वो इससे बड़ा है इस पॉइंट से, है ना? वी आर टॉकिंग अबाउट एनी पॉइंट, वी आर टॉकिंग अबाउट दैट इज this is minimum. Why? Because if we talk about any point in the neighborhood, that is always greater than this point. So that's why it is local minima. ठीक है? Same thing we are talking about in 2 dimension. अगर हम 0, 0 की बात करते हैं, 0, 0 के पास में हम कोई भी पॉइंट जाते हैं, सपोज वी आर टेकिंग x इक्वल टू 0.1 एंड y इक्वल टू मे बी 0.1, ठीक है ना? तो यहाँ पे जो फंक्शन की वैल्यू होगी 0.1 और 0.1 पर, दैट विल बी ग्रेटर देन f of 0, 0, बिकॉज 0, 0 पे फंक्शन की वैल्यू क्या है? 0. एंड इट इज ऑलवेज पॉजिटिव बिकॉज एक्स स्क्वायर प्लस वाई स्क्वायर होने की वजह से क्या हो रहा है? इट इज ऑलवेज पॉजिटिव. सो दैट्स व्हाई दिस 0, 0 पॉइंट इज द लोकल मिनिमा पॉइंट. अगर यहाँ पे कुछ और साइन होता तो वी कैन थिंक अबाउट इट, बट इन दिस केस इट इज क्वाइट क्लियर कि 0, 0 जो है वो सिर्फ फंक्शन की वैल्यू 0 किस पर आएगी? सिर्फ 0, 0 पर आएगी, ठीक है ना? उससे अलावा हम कोई भी पॉइंट उसकी लाइक वी आर टेकिंग एनी वैल्यू ऑफ x एंड y, it is always greater than 0. That's why this 0, 0 is a critical point and it is the minimum point. Okay, or it is the point where the function is having minimum value. So 0, 0 is local minima. Understand? And it is local minima as well as it is global minima. अगर हम कोई भी point और भी लेते हैं, it is not only here, it is like for any value of x and y, it is always minimum. 0, 0 is always minimum point. Okay, so it is local minima, and also we can say 0, 0 is global minima. ठीक है? Understand? One more thing.
Yes, ma'am.
So what we discussed in here, we have discussed local maxima or minima may occur at 3 points. What are those points? First, where fx equal to 0, fy equal to 0, where this is one point. Second is what? Where fx or fy may not exist, or both doesn't exist. Okay, either one of fx and y or both does not exist. And third is what? Boundary point. ये जो 3 conditions हैं, these are only sufficient condition, but these conditions are not like it is not always कि ये condition अगर satisfy नहीं करेंगे तो हमारे पास maximum minimum exist नहीं करेगा. These are only necessary condition but not sufficient. ठीक है ना? How we'll discuss with the help of one example. So the above 3 conditions, the above three conditions are necessary but not sufficient. We will discuss it with the help of one example.
Ma'am,
Okay.
which one? Like fx is
fx
0.
equal to 0.
Okay.
Fx may not exist or fy may not exist or both may not exist. This is the second condition. Third condition, boundary point. है ना? I told you कि maximum minimum may occur at boundary also. ठीक है? These three conditions. ठीक है? So these three conditions are necessary but not sufficient. Okay, so it implies that there is a possibility. So what does it mean? There is a possibility that maxima, minima occur at a critical point. Critical point or boundary point but it is not sure. ऐसा जरूरी नहीं कि हमेशा ऐसा होगा कि इन तीन जगह पे ही हमारा मैक्सिमम मिनिमम आएगा, किसी और पॉइंट पे भी हो सकता है. ठीक है, so उसके लिए हमारे पास different tests होते हैं that we'll discuss later on. Let us do one example, after that we will discuss about it. So find the local extreme value. Find the local extreme value. Find the local extreme value, if any, for the function f of xy equal to y square minus x square. Okay, the function is what? That is y square minus x square. Solution. Again, in this case, there exists this function is what? Y square minus x square. Point for all value of x and y. So again, there is no boundary. There is no boundary. There is no boundary. And then, so जैसी boundary नहीं होगी, तो we will not check whether like one out of these three conditions, one condition is will not be considered. Okay, so it is neglected. So now we will talk about.
ये कौन सी shape बनेगी मैम?
देखिए अब कौन सी बनेगी, y square minus x square. That we have to let me explain it first, then we'll tell you what shape we will get. है ना? अगर हम देखते हैं y square minus x square equal to 1, so like first we will go along x-axis and then y-axis, then we will discuss. Okay, I will write it. So there is no boundary. It is clear.
It can be like a circle in third quadrant.
Yeah, something like that. Y square minus x square equal to 1. You can just think about it. So y square minus x square depend कि आपका क्या आता है, क्या value ले रहे हो. Okay, it's not like if we are taking suppose x equal to 0. Let us talk about let us suppose along x-axis. Along x-axis. So what you will get? X-axis, that means y equal to 0. So what you are getting here from here? X square equal to minus x square equal to 0. Sorry, f of xy equal to suppose minus of x square. ठीक है ना? So fxy तो आपका ये आ गया ना, y equal to 0. So if we are drawing this graph, I'll show you like somewhere here. Just a minute. This is suppose this is y-axis, this is x-axis, y-axis, z-axis, and let us suppose z we are denoting by fxy. Fxy equal to y square minus x square. If we go along this y-axis, so what we are getting? This is minus x square along y equal to 0. So y equal to 0, that means this x-axis. Okay, it is coming out to be negative, something like that. Something like that. अगर हम सीधा सिंपल x और y एक्सिस में देखते हैं तो यू आर गेटिंग माइनस एक्स स्क्वायर, सो यू आर गेटिंग नेगेटिव वैल्यू है ना, y इक्वल टू minus x square suppose, so you are getting something like that, always negative value, something like that. But since we are talking about in 3 dimension, then it is the value.
Ma'am, how to figure it out that it is in 2 dimension? It is means boundaryless or with boundary?
Pardon?
Ma'am, how to check that it is boundaryless or it is in some boundaries?
Actually अगर हम इसकी बात करते हैं y square minus x square के fx y equal to y square minus x square, so this function is defined for all value of x and y or not?
Yes, ma'am.
तो डोमेन हमारा क्या है, r स्क्वायर, तो r स्क्वायर का मतलब क्या है, r क्रॉस r, x की वैल्यू कहां से कहां तक लाई कर रही है, माइनस इंफिनिटी टू प्लस इंफिनिटी, एंड y इज आल्सो लाइंग फ्रॉम माइनस इंफिनिटी टू प्लस इंफिनिटी, so that means what, whole xy plane, that's why there is no boundary ना. अगर हम इसकी बात करते हैं, सपोज y स्क्वायर माइनस x स्क्वायर इक्वल टू,
Understood, ma'am. Thank you.
Ma'am, so for checking the boundary, we have to check the domain for every function.
This is what if we are talking about only along x-axis. Sorry, along x-axis y square equal to 0, so we are getting this fx 0 equal to minus x square. It is something like parabola kind of thing, minus of x square. It is the like it is below y-axis, है ना? If we are talking about let us suppose along y-axis, so along x-axis y equal to 0, so we are getting here minus of x square, so it is always less than 0 no? Because minus of x square, x is always positive, whatever x value you are taking, but minus x square it will be less than 0. Okay, along y-axis, along y-axis का मतलब क्या होगा कि x equal to 0 है, along y-axis x equal to 0, so f of 0 comma y, okay, it is coming out to be y square, it is coming out to be y square, so it is greater than 0. So if we draw it here, it is coming out to be something, this is y-axis, this is z-axis, to something like, if we're talking about, ठीक है ना, something, this is the shape whenever you are taking along x-axis. So x के लिए क्या होगा, x equal to 0, like along y-axis you are taking, then this kind of shape you are getting, है ना? That means f of 0 y equal to y square. This f0 y means what, you are getting some values, that's why you are drawing this, no? So we are getting this kind of shape. It isn't. So you were asking what kind of shape we will get, so you have to draw in this way, otherwise we have to draw surface properly. ठीक है ना? So now let us come to the question. What is your question? Find the local extreme value, if any, for the function. So again, what is the procedure to compute extreme value? We will put f of x equal to 0. F of x equal to 0 means what? Differentiation of this function. So minus 2x equal to 0, and f of y equal to 0, that is 2y equal to 0, this value. So we are getting 0, 0. This implies that x equal to 0 and y equal to 0. So 0, 0 are the critical points. So यहाँ तो exist कर रहे हैं ना, are the critical points for this function. ठीक है? So here we can say the partial derivative. So let us write the partial derivative fx and fy.
Excuse me, ma'am.
Yes. Yes.
मैम
बोलिए.
एक रिक्वेस्ट थी
अच्छा.
मैम, प्लीज आप हिंदी में पढ़ा दिया करोगे?
यस मैम.
Okay. So but थोड़ा बहुत इंग्लिश भी होना चाहिए ना, वरना आपको आगे.
नहीं मैम, थोड़ा बहुत ठीक है मैम, वो तो चलेगा, कोई बात नहीं.
ठीक है ना? So fx and fy exist everywhere. ठीक है? Therefore local extreme का मतलब क्या है? मैक्सिमा और मिनिमा. ठीक है ना? लोकल एक्सट्रीम वैल्यूज है ना, एक्सट्रीम वैल्यूज भी बोलते हैं, एक्सट्रीमा भी बोलते हैं, लाइक कैन अकर only at the origin. ठीक है, आपका like ये point आपका क्या रहा है 0 0. This is the critical point 0 0 and this is the origin, है ना. If we are talking about along x-axis, however, along, explain this point. However, along the positive x-axis, the positive x-axis, positive x-axis का मतलब क्या है? Like this. However, along the positive x-axis, f has the values the fx0. Positive x-axis का मतलब क्या? We are taking any value of x in the positive side. So it is coming out to be what? Minus of x square from the function, है ना? आपके पास function की value क्या आ रही है? It is coming out to be minus of x square. चाहे आप x की value positive रखें या minus रखें, you are getting always minus x square. ठीक है? If you are talking about along,
Could you just repeat what you just said?
just a minute, just a minute. Positive y-axis. Let me write and then I will explain. Positive y-axis, f of 0 comma y, it is coming out to y square greater than 0. What I'm saying here, it is x-axis. This is your x-axis, this is your y-axis. Okay. From here, we are getting this condition. F of x comma y equal to y square minus x square. Okay, if we are talking about positive x-axis or y, so it is x comma 0. Let us say x positive. So x0 is what? It is minus x square. It is always less than 0. F of 0y, if we are talking about 0y, it is coming out to be what? It is y square. It is greater than 0. ठीक है ना? और हमारे पास minus x square का मतलब क्या है? Negative value. And this is what? Y square, that is positive value. X की आप positive value रखिए या negative value रखिए, it is always coming out to be negative. तो function value जो आ रही है वो आपकी negative आ रही है in this case, and function की value जो है वो आपकी positive आ रही है in this case. Y को अगर positive लेते हैं, negative लेते हैं, doesn't matter, it is always positive. And X को अगर हम positive, negative कुछ भी लेते हैं, it is always coming out to be less than 0. तो एक तरीके से हम अगर बात करें तो ये point आपका क्या है 0 0 है ना. आपकी जो वैल्यू 0 0 क्या है आपका क्रिटिकल पॉइंट है, ठीक है ना. बट फंक्शन जो है एक साइड से वैल्यू इसकी नेगेटिव आ रही है, फंक्शन की दूसरे साइड से पॉजिटिव वैल्यू आ रही है. तो इसका मतलब क्या है कि here it is positive and it is coming out to be negative. तो 0 0 है, neither 0 0 is minimum value or nor it is a maximum value. ठीक है ना.
Ma'am, so you're saying like in the very first part, at x equals to 0, so over there, we get like minimum, we get maximum value, and at f0y we get minimum value. So
Yeah.
because of that, like we get both the values, but in different cases. So
Yeah.
that's why there would be no value.
Yeah, like if you compare this with the previous example, like if it is a 0 0 point, all values due to this x square plus y square, you are having always greater values. But in this example, you are having, in this example, for the 0 0 point, fx0 तो आपका negative आ रहा है, f0y it is coming out to be positive. So in the neighborhood 0 0 के अगर आसपास देखते हैं, like some values of the function are positive, some values are negative. That means 0 0 is 0 0 will never be a minimum point nor a maximum point. So this is the thing I'm saying here.
Excuse me, ma'am.
Yes.
Ma'am, fx is 0 when negative when there is only x component, and positive when there is y component. So how they are two different components, how we are correlating them together?
Actually, you are in 2 dimension, no? You are in 2 dimension, like it is something like that. It is 0 0 point. ठीक है ना? And we are talking about any point in the neighborhood. We are talking about any point in the neighborhood. Like there are infinitely many points. So we are doing what? We are taking, this is suppose y-axis, this is your x-axis. ठीक है ना? So we are talking about y-axis. तो y-axis आप जैसे ही लेते हैं, suppose y-axis पे हमने लिया कोई भी point. So you are taking 0 1. ठीक है? So what is coming out to be? Function आपका जो है fxy equal to x y square minus x square. ठीक है? तो f01 is what? It is 1. And f of, if we are talking about x axis, क्योंकि 0 0 पॉइंट को क्या कवर करेगा, पूरा ये सर्कल कवर करेगा. तो 0 0 के नेबरहुड में क्या है? All these points are in the neighborhood. And let us talk about a particular point on the x-axis. So suppose 1 0, so it is coming out to be -1. तो फंक्शन वैल्यू अगर हम 0 0 के आसपास देखते हैं तो 0 0 के आसपास जो है लाइक इन द नेबरहुड ऑफ 0 0 you are having some values positive, some value negative. So like as per definition of maximum or minimum क्या होना चाहिए? This should all the function value in the neighborhood, they should be greater than 0 0. ठीक है ना? fxy should be greater than this 0 0. Then we'll say this fxy is what? Maxima. ठीक है? This function is maximum. Or you are having this condition fxy is less than f of 0 0, then we'll say it is minima. But in this case, if for all xy, but in this case, due to this function, some values are like we are taking a particular value 0 1, it is positive, and another value is what? Negative. So some values are greater and some values are less than 0. So that's why we are saying it is neither maxima nor a minima. Understand or not?
Yes, ma'am. Understood.
ठीक है ना? तो चूंकि हम 2 डायमेंशन की बात कर रहे हैं, so we cannot take a particular point like left side, right hand side will not check. We will check in the neighborhood. जैसे कि आप एक छोटी सी जगह पे रहते हैं and neighborhood means what? Like all the points. ठीक है ना? तो suppose this is your house, then all the houses like left side, right side, front, all they are all in your neighborhood. The same thing is in 2 dimension. It is a 0 0 point, and if you are taking like there are different point in the neighborhood, so we are taking particular 2 points along y-axis, x-axis, because you can visualize it nicely. That's why I'm taking these 2 points. तो हम इसके आसपास देते हैं like 1 0 we have taken, that is coming out to positive, and 0 1 we have taken, it is positive, and 1 0 it is coming out to be negative. And 0 0 पे function की value क्या है? It is 0. So ये तो है, the 0 is lying between this value -1. So some values are less than 0 and some values are greater than 0. That's why 0 0 is neither maxima nor minima. ठीक है ना? That is the reason. So something like you can say something situation is something I can show you with the help of some figure. Maybe then it will be easy to understand. And it is not just a minute. I'll show you just with the help of one example I have in my. This is the example. So you can see from here. Is it visible?
Yes, ma'am.
Is it? So in this particular example, this is the figure for z equal to y square minus x square. So I don't know whether I will be able to write. I'm not able to write here. So just you see this 0 0 is the point. Here it is the 0 0 0 point, and some point are above and some point are below this point 0 0. That's why this 0 0 is neither a maximum nor a minimum, if this figure is clear. So this kind of point are called. So the point, critical point where function is having neither maximum value nor a minimum value, then we'll say that point, those points are called saddle point. Understand? So this figure is like quite interesting. Here everything is visible. अगर किसी को कोई confusion हो तो पूछ लीजिए इसमें. So if you want, then we can, this point is what? This is your 0 0 point. So if you see from here, ये वाला जो point है, this is below, and this is what? This is above to 0. That's why. So that's why it is neither a maximum nor a minimum. Understand? So this point called saddle point.
मैम इस क्लास की रिकॉर्डिंग कब तक डालोगे आप?
आज आते हैं. ठीक है, अभी डाल देते हो, इसको खत्म करते हैं. So let's
Okay.
finish our class here. I think time is over.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Thank you, ma'am.